Welcome to the final question from the August 2017 Algebra Regents exam, question number 37. So we've got Zeke and 6 of his friends going to a baseball game. Combined money totals $28.50. At each game, hot dogs cost $1.25 each, hamburgers cost $2.50 each, and sodas cost 50 cents each. It also tells us that each person buys one soda, and they spent all of their money on all the food and drinks. First part, write an equation that can determine the number of hot dogs, X, and hamburgers, Y, Zeke and his friends can buy. We know that each hot dog cost $1.25 each. Okay, so the first part is we're going to take $1.25 and multiply it by the number of hot dogs that they're buying, which is represented by the variable X. Similarly, we're going to do a similar thing with hamburgers, but this time they cost $2.50 each, so we'll do 2.5, no point writing the 0. And we're going to multiply it by how many hamburgers they're going to buy, which is represented by the variable Y. And finally, sodas, we don't need a variable because we know that each person buys one soda. If each soda costs 50 cents, and there are 7 people in total, right? Zeke and 6 people is 7 people in total. That would end up being $3.50 or 3.5 that they're spending on the sodas. So we could add 3.5 to the equation. And we know that the grand total that they're spending is $28.50. Now, we probably should simplify this a little bit. We could subtract 3.5 from each side of the equation. So it would actually become 1.25x plus 2.5y equals, and then 28.5 minus 3.5 gets us an even 25. So that's the equation that we could use. Part 2 says to graph the equation on the grid below. Now, in order to graph this sucker, we need to isolate y. So we're going to do that next. We can start by subtracting 1.25x from both sides. So we would get 2.5y equals negative 1.25x plus 25. And then to completely isolate y, we would divide each term by 2.5. Negative 1.25 divided by 2.5 gets us negative 1/2. So we'll get negative 1/2 x. And 25 divided by 2.5 gets us positive 10. Now that we have this equation written in slope y-intercept form, it's a lot easier to graph. We know our y-intercept is 10, and our slope is negative 1/2. So let's go ahead and zoom in here. Figure we might as well start by labeling our axes. So along the bottom, we'll have the number of hot dogs. And along the y-axis, we'll show the number of hamburgers. Okay. So our maximum y-intercept is 10. So 2, 4, 6, 8, 10. That's right here. And because our slope is negative 1/2, that means we're going to fall 1 and run 2 to the right, just like this. And we're going to keep following that pattern. All the way to this point. So each of these points represents a possible scenario of how many hamburgers and hot dogs they can buy with the amount of money they have, right? So if they bought 10 hamburgers, it means they could buy 0 hot dogs. If they bought 5 hamburgers, they could buy 10 hot dogs. And if they bought 20 hot dogs, they would buy 0 hamburgers. And also because this is not a continuous relationship, you can't buy a fraction of a hamburger or a fraction of a hot dog, we should not connect these dots. Okay, final question. It says to determine how many different combinations, including those combinations containing 0, of hot dogs and hamburgers Zeke and his friends can buy, spending all of the money, and explain your answer. So as I was just explaining, each dot here represents a different possible scenario in which they can buy different combinations of hot dogs and hamburgers. So let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I just typed in my explanation there. I said that there are 11 different combinations because each dot on the graph represents a different possible combination or situation. And that's it for this video. Hope that was helpful, and thanks for visiting JD's Regents Preparation.